It's the largest passenger aircraft ever built, an engineering marvel that looks unstoppable from the ground. But watch closely as it takes off, and you'll notice something strange. That massive body, powered by 4 engines producing nearly 300,000 pounds of thrust, climbs with all the enthusiasm of a freight train on a hill. While smaller jets like the Boeing 777 or Dreamliner rocket upward at 3,000 feet per minute, the Airbus A380 drags itself into the sky at half that rate. It's not a malfunction, not a pilot error. It's physics flexing its muscles. The A380 was born to dominate the skies but ended up shackled by the very laws of aerodynamics it tried to outsmart. And what's even more fascinating, this wasn't an accident. Airbus built the A380 to be big, bold, and beautiful, but in doing so, they created a flying paradox. A jet so advanced it exposed the limits of modern aviation itself. Here's where the illusion falls apart. The A380's thrust-to-weight ratio is just 0.23, far below the 0.3 of the Boeing 777 or the Dreamliner. In simple terms, for every pound of weight, it has 23% less push than its competitors. That's like putting a V8 engine on a semi-truck and wondering why it doesn't sprint. Despite having 4 engines that could individually power a smaller jet, the A380's 1.26 million pound body drags everything down. When fully loaded, it can barely climb at 1,500 feet per minute, numbers that make pilots wince. Compare that to newer aircraft soaring twice as fast, reaching efficient cruise altitudes in minutes. The A380's slow climb means more time in dense air, more fuel burned, and less profit per mile. Behind its quiet luxury lies a brutal truth. Those beautiful wings are fighting gravity with one hand tied behind their back. During development, Airbus faced an impossible choice: build the perfect wing or build an airport-friendly plane. Airports worldwide had infrastructure limits, with an 80-meter maximum wingspan for compatibility. The engineers knew an optimal A380 wing needed to stretch to 90 meters, but that would have forced every airport to rebuild gates and taxiways. The decision was made: trim the wings. That one compromise sealed the A380's fate. A shorter wing meant a lower aspect ratio, 7.5 instead of the efficient 9 found on modern jets, more drag, less lift, slower climb. Every time an A380 fights through the air, it's paying the price for that decision. Airbus engineers tried to mask it with technology and smart flight systems, but physics doesn't play favourites. You can't make a heavy jet dance when its wings were cut short before it ever left the drawing board. Scaling laws are cruel. Double a plane's size and its weight increases eightfold, but the lift only quadruples. The math isn't negotiable, and the A380 became a victim of it. Even its massive wings can't keep up with its body's bulk. And when the jet leaves the ground, things get worse. Within about 40 meters of altitude, it loses the aerodynamic cushion called ground effect, like a bird leaving a thermal current and suddenly feeling the full pull of gravity. That's the invisible wall you see in takeoff footage, where the climb suddenly flattens. The A380 isn't struggling because it's flawed. It's struggling because nature demands balance, and no amount of engineering can rewrite that equation. In trying to build the biggest, Airbus discovered the boundaries of what bigger can achieve. Ask any A380 pilot about climbing, and you'll hear the same phrase: step climbs. Unlike modern twins that soar straight to 41,000 feet, the A380 must inch upward like a mountain climber stopping for breath. Start at 33,000 feet, burn some fuel, request 35,000, then 37,000. Sometimes air traffic control denies the request, leaving the aircraft stuck in turbulent air, burning thousands of extra kilograms of fuel per flight. Each denied climb adds cost, delay, and inefficiency. The jet's own manuals politely call for special attention during climb, which is aviation code for don't expect miracles. Passengers enjoy a smooth ride without realizing the pilots are wrestling gravity and fuel math in the background, praying the next altitude block opens up before the turbulence hits. The A380's competitors didn't just beat it, they embarrassed it. The Boeing 777-300ER, a twin-engine workhorse, climbs faster, flies higher, and burns less fuel while carrying nearly as many passengers. The A350-1000 takes that further, reaching optimal altitude in half the time and maintaining efficiency across the entire flight. Even the older 747-400 climbs better than its younger giant sibling. These newer designs use lighter composites, smarter aerodynamics, and advanced flight computers that adapt to changing conditions. The A380, by comparison, feels like a heavyweight boxer in a featherweight league. While its rivals cruise above the storms, the Super Jumbo is still dragging through thicker air, paying the price for every unnecessary pound of lift it must generate. Only one airline managed to make the A380 truly work: Emirates. With over 120 in its fleet, they turned a limitation into an advantage. By building an entire system around the aircraft, custom gates, specialized crews, optimized routes, they achieved what others couldn't: profitability through scale. Tim Clark, Emirates president, once said, "If you have 10 of them, it's a nightmare. If you have 100, it works, but even Emirates can't escape physics." Their A380s still step climb, still burn more fuel at lower altitudes, and still require special handling from controllers. The airline didn't solve the problem. They simply spread the pain across enough flights to make the math work. For everyone else, the economics collapsed, and the age of the Super Jumbo faded into the clouds. In the end, the A380 story isn't just about slow climbs, it's about ambition versus reality. Airbus built the ultimate passenger experience: quiet, stable, and majestic. But airlines don't buy dreams, they buy efficiency. Each extra minute the A380 spent below cruise altitude was profit burned away in jet fuel. The jet proved that size doesn't equal success, and that optimizing for airports, not aerodynamics, can cripple even the most advanced machine. Today, the A380 remains a legend in the sky, an icon passengers love and engineers quietly study as a warning. Watch one rise from the runway, heavy and determined, and you're witnessing the last chapter of aviation's giant era. And if you've enjoyed uncovering the secrets behind this flying titan, help this channel climb a little higher too. Hit that subscribe button, drop a like, and tell us in the comments, was the A380 a masterpiece of design or a monument to ambition that went too far?